Hey, so we are back with Curious Jay. We have more stuff here where you took a trip
Yeah,
to
yeah.
New Orleans and you decided to do some tests. And we have a couple photo albums here, so it's going to be like a two-part video. This album is called Curve. So explain the experiment that you did when you took your trip to New Orleans.
Yeah, so nothing new and groundbreaking here. I've seen lots of curvature tests when it comes to the flat earth, globe earth debate online. But I just it was one of those things where I just had to do it myself, had to see for myself.
Which we tell everybody, we encourage everybody do your own
Do your own
experiments.
research,
Don't
yeah.
take your word for it, mine or anybody else's.
That's right. And it was one of those deals where it's like, just in case everyone else was doing something wrong. So what I did was I went up to, I was in New Orleans, I was on break from work, and I went north of Lake Pontchartrain to a town called Slidell, Louisiana.
I've
Right?
been there.
And yeah, lucky you. And I went down to the beach of the lake, and I placed my camera on a tripod, and it was about 18 to 20 inches, about 19 inches above sea level, right? And I faced the camera southwest towards New Orleans and Metairie. And I've pointed it in the direction of where this building should be, and this is called the executive. There's my tripod.
Let's back it up. This is the Nikon P900, I believe.
Correct.
So that's the one that they shoot the moon with, and they really can zoom in a great deal with
Yes. Yes.
Okay.
Got a very powerful zoom on there. Now, I pointed in the direction of the Executive Tower 1. Okay. This is the tallest building in Metairie, Louisiana, and it sits really, really close to the lake. If you were to Google it, it'll show you it's right on the beach of that lake. But pay attention here. The roof, the height of that building is 204 feet. So keep that in mind, all right? So, and just to show you the distance of where I was to that, you can go to this.
Wow, 24 miles?
Yeah, this is 24 miles from where I was standing to that building, right? And there are no other buildings in Metairie that have the box on the top. You know what I mean? That unique little box on the top. It's a box
And
building
this is
with a
the
box on top.
tallest building, so there's not a mistake that...
Right.
you know.
There's no other buildings. So, but what was really interesting is that I could actually see a little bitty, tiny little blip of, where it was. You obviously can't make out the shape with the naked eye, right? But I point the camera over there, and, lo and behold, let's see how much. Now, before we show how much I can see with the
You're
camera.
going to make them wait.
Make him wait for it. Wait for it.
All right.
So the curvature formula for the Earth curvature is one thing about flat Earth that I haven't found anybody contest. It is legit. And the way you do it is distance in miles squared times 8 inches, right? So 24 miles of distance, right? You basically just take your 24 miles and you multiply it times 24, and you come up with a very large number, 576 times 8, the inches, and you get 4,608. Divide that by 12 to get your feet, and you get 384. All right, so between those two spots, there should be 384 feet of drop in the earth. Okay, that building is 204.
We're going to go
feet.
back to that.
Yeah,
204
that building
feet
is
tall.
204 feet tall. So how much of it should I see? None of it. Correct? It should be
as far as the formula
180
goes.
Feet. That's
Yeah.
right. According to the formula, it should be 180 feet below the horizon. So let's see how much we could see of it in the photos. And there it is. Boom.
It almost looks like an oil rig.
Yeah, that's right.
That's what I thought it was when I first imported it into the Photos app.
Yeah, no, it's and there's no oil rigs currently on the Lake Pontchartrain.
So how much is that? How much of that building is it? I mean, there shouldn't be any, but it looks like there's a great deal of that building.
It's almost all of it, because if you go back and look at the building and you compare the roof, the roof represents a certain portion of the building, and it's you might be able to fit 12 of those roofs.
So it's
vertically
that
down.
little characteristic of that.
Yeah,
It's
and
pretty
so
easy to see.
I would say you see over half the building. So you got about the first 100 feet or so is blocked by the distortion.
Yeah, it's a
and
rough sea or a rough,
Yeah.
body of water. So if it was calm, you probably could see a little bit more of
and
it.
I took several pictures of this thing, and there it is again, right?
Now, this isn't what, like that weatherman said, a mirage, because I thought those characteristics were just for the Great Lakes region. This is nowhere near the Great
No,
the
this is
Great
nowhere
Lakes.
near the Great Lakes, and I assure you it's not a mirage, because mirage. I actually watched a flat Earth debunking video the other day, and they were talking about how the reason that these pictures are doing this is because of mirages and atmospheric conditions, etc. This can be seen on just about any day, unless it's like really, really cloudy where the clouds are low, and it's just a horrible day where you can't see, a mile in front of you. You can see this anytime, all right? Doesn't matter if it's hot or cold in New Orleans. You'll get this deal. But what the guy was saying on the video is like, that's why people show photos, but they don't show videos, because if they did, what you would see is a building that's like appears to be waving and moving with the air, because it's a mirage.
I imported the video, so I guess we're going to get that in a second.
So I took several pictures, and I took a little clip of the video. There's another one, and so here's the video, and there we go. There it is. You can see the waves are moving.
So you're on a tripod on the beach. You're not moving around.
Correct. And this is my phone filming what the camera was seeing. You with me?
Yeah.
So that's why the camera was moving. The phone camera, was moving. But yeah, I was on a tripod 18 inches above sea level, looking straight that direction, and boom, there it is. So where there should be 384 feet of curvature, I got about I'd say 80, 90 feet of the bottom of the building is blocked. That's
now let me ask you a question. This formula is a formula when you have a heliocentric model, just a completely round Earth, correct?
Spherical Earth, right?
Yeah, spherical Earth. So Neil deGrasse Tyson himself and everybody in that realm of experts has said it is an oblate spheroid. So it's not exactly anywhere close to what we think of as a sphere. Mm-hmm. So wouldn't that make this calculation, this formula, just
different,
null and void? Why would like I always say, if you say it's an oblate spheroid, it's pear shaped, it's bulging, it's whatever at the center. Why are the globes still globes? Why is this formula still a valid formula? This is lazy science at the very least criminal. This is lazy science.
Well, here's my point with the oblate spheroid. Let's just assume for a second that it is an oblate spheroid and ignore every picture of Earth we've ever seen. Because every picture of Earth we've ever seen represents it as a sphere.
Because that's what you essentially say if it's mainstream media saying now it's an oblate spheroid, everything the whole house would come crumbling down.
Yeah, I mean it effectively, like I think we've said it on or I think I may have said this on another video. One of the two is wrong. Either the pictures that NASA has given us are BS, or the oblate spheroid idea is BS. Because the pictures from NASA don't show an oblate spheroid. They show a sphere.
And if it is an oblate, if why would they make the claim that they're going to be wrong either way?
Right. Right.
They're wrong either way. The formula's wrong, or the counter.
Yeah, but for the formula's sake, let's assume for a second it's an oblate spheroid. Well, the problem you have is that this video here is from Louisiana, but there's people taking these videos and pictures in Australia and England and
it's not just Kansas where it's famously flat.
It's not one little area. This is everywhere. And the problem you would have is like, let's say, like you said, well, it's an oblate spheroid, and that area right there, that 24 miles, is a little bit flatter than the rest. Well, that means that to make up for it, to get us even close to a sphere, the next 25 miles would have to have double the curve. Mm-hmm. So you'd be able to easily see it.
It all has to even out in the end.
It's got to even out. It's got to average out. So even taking into consideration the oblate spheroid, I'd say that, okay, for every time someone gets a shot like this, well, you should be able to raise a helicopter up, a mile up, a plane a mile up, and you should be able to, with the naked eye, see that curve because it's so steep to make up for all those flat areas people have been filming. You see what I'm saying?
I do. The other people, they'll probably counter with something in the comments, but it's.
And I want to say one more thing about these photos.
Sure.
When people, the biggest argument I've seen against stuff like this is producing another photo where, look, this much of the building is blocked and that's how much curve it should be or whatever. You can't debunk this photo with another photo. In other words, if I show you a picture of a guy with 3 heads, don't show me a picture of a guy with 1 head as proof that that my photo's fake. Does that make sense?
Understood.
You
Yeah.
need to explain to me the phenomenon that is going to cause me.
That's what they use. There's some phenomenon that can't be proven
That's
to
right.
say, well, that's right. That's a it's reflection of light. It's a mirage. It's the time of day. It's the fact that you were using
But
a
no one can
Nikon.
demonstrate
Nikon's never shoot the curvature.
That's right.
You always shoot it flat.
That's right. That's
You know
right.
what I mean,
It's
well,
the
I mean,
lens.
we're only one step away from that reason.
Yeah, you're right. You're right. But point being is that you can't argue with, hey, go look at this video of the Toronto skyline where 300 feet are blocked and you can see the top half but not the bottom, and that shows the curvature. Don't show me a photo of supposed curvature to debunk my photo. All I need to see is one picture where curvature that should be there isn't, and you as science or as researchers need to explain why I'm seeing something I shouldn't, and you need to show me a demonstration that would prove your theory as to why I'm seeing it. Don't say atmospheric refraction. Don't say mirage. Show me how that's done.
So this is the end of the video where you leave it to people in the comments to prove
Yes,
you're wrong. Okay,
correct.
just checking.
Yeah, that's
All right,
it.
guys, have fun with it.
I'm dropping the mic.